हाय गाइस, वेलकम टू कोडिंग वर्ल्ड। तो इससे पिछले वाले वीडियो में हम लोगों ने देखा था कि कैसे हम लोग टॉप डाउन मेथड रिकॉर्डिंग इज डन। टॉप डाउन मेथड से हम लोग कैसे डीपी के प्रॉब्लम दैट मीन्स फिबोनाची के एक प्रॉब्लम हम लोग देखे थे टॉप डाउन मेथड से। नाउ इन दिस वीडियो वी आर गोइंग टू डिस्कस अबाउट बॉटम अप अप्रोच। ओके, सो लेट मी टेल यू बॉटम अप डीपी. व्हाट इज बॉटम अप डीपी? सो see it is bottom up DP solution. Okay, bottom up DP solution also known as tabulation method. Okay, this is an iterative solution. See why it is called as bottom up DP, I will tell you in this video. Okay, this is an iterative solution. You can write it by yourself. This is an iterative solution. Okay, now what is let me tell you the Fibonacci of n. It is having three basically this is the recurrence relation, recursive function. It is 0 if n is 0, it is 1 if n is 1, and it is fib of n minus 1 plus fib of n minus 2 if when n is greater than equal to 2. Okay, if n is greater than equal to 2, then definitely we are going to have. So in this iterative solution we will maintain an array of n plus 1 element, and at 0th index and 1 index I will fill 0, 1 and 2, means from 2 and 2 onwards, we'll say we'll have infinity. So we will fill all infinity. See why I am maintaining at 0 index the value is 0, at 1 index the value is 1, and from 2 index there is all infinity. Why? See whenever there is when my n becomes 0 or n becomes 1, then definitely I do not have to compute anything. I definitely go to this array and I will simply get this value. Okay, simply get it. Suppose how you can get the value from array? You have to we have to create a variable and say I am writing array as 0. See what it will do? It will do nothing. What is the value at 0th index of this array? That is 0. So x will be 0. And suppose if I am writing here it as 1, so what will be the value of x? The value of x will be 1. Okay, so basically this is the initialization part. Basically there are 3 steps in initialization. The first step is at 0th index make it 0, means the value at put the values as 0, and at 1 index put the value as 1, and from 2 onwards put the value as infinity. Now what I will do, I will simply for int I equal to 2, I will start from 2 index, because 0 and 1 anyway I know it. I will go till the last index, basically and I plus plus. Okay, it will be included. Okay, why included? Because we have to include this, because at nth index we are returning the value. At nth index the fib of n has its answer at nth index. Okay, so what it will do? It will do nothing. Okay, it will do nothing. What it will do? Okay, here it should be array. Okay, it should be array of I is nothing but array of I minus 1 plus array of I minus 2, and that's it. And after this for loop we're gonna return array of n index. So let me dry run this code, okay, so that you can grasp this concept. So this is the ending of this for loop. Basically this is the complete coding part. Okay, now let me dry run it so that you can get it very clearly. Okay, say when I becomes 2, so here I is 2, so what it will do? I is 2, so what is I minus 1? 1, and what is I minus 2? It is 0. So what is the value of array at 1 index? It is 1. Okay, 1 plus, because there is plus, array of 0th index, that is value at 0, that is 1. So now you can say that array of I here I becomes 2, so what it will do? It will just replace this value as 1. Okay, now let me dry run for another value. Suppose when now I plus plus, so now I becomes 3, so what is I minus 1? 2. What is 3 minus 2? It is 1. So go to the 2th index, that is 1, and 1th index, that is also 1, and add this one. So basically at 2 index we have value 1, so let me make it 1. plus at 1th index it is also 1, so plus 1, and and 1 plus 1 is 2, and 2 will be assigned at 3rd index. Now also initially I have initialized this array at 3rd index, that is infinity, but now it will, suppose this is the 3rd index, now it will not be infinity, it will be 2. You can see that this is the thing. Suppose what will happen, let me run for one more time. Okay, now suppose I becomes 4, now here is 4, so 4 minus 1 it is 3, and 4 minus 2 it is not 1, it is 2. Now 4 minus 2 is 2, 4 minus 1 is 3. Now check for array at 3rd index, what is the value? 2. Okay, let me write 2 plus. Now check what is the value at 2nd index of this array, that is 1. Add it, now it becomes 3. 3, where 3 will be assigned? At index 4. So let us say that here it is 4, so here it will be assigning as a 3. In this fashion it is calculating. Suppose whenever I'll call for I equal to 5, then definitely these two values will be getting added, and we are getting 5, and so on and so forth. Now suppose when I becomes n, now I becomes n, what will happen? It will call for n minus 1 and n minus 2, and whatever the value to definitely previously it has been stored, and now the two values will be getting added, and it will be stored at nth index, and this value is my final answer, and hence I am returning this. Why I am returning this array of n? Because at nth index I got my answer. So in this way, bottom up DP. See why I am saying bottom up DP. Suppose for let me make here. Suppose for n equal to 5, suppose this is the value of n, we are going to call for 4 and 3. For 4 and 3 we are going to call for 3 and 2. For 3 and 2 we are going to call for 2 and 1. For 2 and 1, 1 and 0, and definitely it will stop at 0. Basically 1 has the value as 1, so 1 will be returning to its parent. This is the parent, this is the children. 3 will be 2 and 1, and 2 again going to call for 1 and 0, and both 1 is returning 1 and 0 is 0, so 1 plus 0 is good, so 2 will get as 0, and 1 anyway 1 is 1, so 1, so 1 plus 1 2, so this function, this 2 will return 2 to 3 in this now see, when 4 will get its value, when 4 will only get value when 3 and 2 both compute itself and return to 4. When 3 will get value when 2 and 1 both get its value computed and return to 3. So you can say that 4 will get value only when 3 will return to 4. 3 will get value only when 2 and 1 both will return to 3. 2 will get value only when 1 and 0 will return to this. Now so why it is called bottom up DP? Now see, this is called bottom up DP because we are starting from bottom. See, this is the recursion tree. Now we are starting from bottom and we are going to top. Hence this is known as bottom to up DP. That is why its name is bottom up DP, because we are calculating from the bottom. See, here it is calculating these two values I have already calculated. Now from 2 I have started, from bottom I have started. Tick. Definitely you can see that whatever the value bottom, from bottom the functions are getting value computed, I am storing in this array. So definitely one function is going to be called only once, and this is an iterative solution. This is not a recursive solution. Okay, this is an iterative solution. So this is an iterative solution. Also I have in the beginning of this tutorial I have told you that this is an iterative solution, and this is also known as tabulation method. So for each and every problem that can be solvable by DP, we'll talk about only two methods, that is bottom up DP and top down DP. In top down DP, in previous video I have already told you that in top down DP we are going from top to bottom. That's why its name is top down DP, and it is also known as memoization. Okay, now I'll also talk about various types of problems and I'll code it. In next video I'll talk about LCS, that is longest common subsequence, and then I will there are various kinds of problems that can be formed on dynamic programming. Basically my focus here is to solve some advanced type algorithms, like how you can approach 2D grid problems. Okay, 2D grid problems, that means given a matrix we will be given also some queries, and we have to approach that queries in big O of n time. Okay, we'll discuss all these things in detail. Also we'll talk about job sequencing problem. What is this? We'll talk about in further videos. Now let me tell you one thing more, that what is the application of dynamic programming. See, the application of this dynamic programming can be seen in back propagation. See, what is back propagation? This is an algorithm. This is a kind of algorithm that is bottom up DP algorithm. Hence, in this fashion, back propagation is also an algorithm in AI. AI means artificial intelligence, in the chapter of in the context of machine learning, that is ML. See, in back propagation we use nothing but we use only DP, that means dynamic programming. See what I'm saying. The application of dynamic programming, one of the very important application and very vast application of DP is back propagation, which can be used in artificial intelligence, that is in machine learning. But see, my main focus here is to cover data structure and algorithm, but I will also in the subsequent videos I will talk about what is back propagation, what are the different algorithms that can be applied in back propagation, and how can we approach this back propagation algorithm in solving problems with the help of DP.